What if I told you that quantum mechanics isn't the weird one? Classical mechanics is, it only feels weird because you're used to a world where everything behaves like numbers. In that world, everything is simple. X is position, P is momentum, they're just variables. And if they're just numbers, order doesn't matter. Swap them, nothing changes. So you'd expect position into momentum equals momentum into position. They should be the same, right? But quantum mechanics says no. The problem is simple. We're using classical intuition to understand something deeper. Here's the shift. X and P alone no longer define the system. What defines the system is the state, and X, P aren't values. They are actions on that state. So now, order isn't arithmetic, it's physical. Compare XP psi and PX psi. They look the same, but they aren't, and the difference doesn't cancel. It leaves something real. XP minus PX equals I H bar into I, where I is the identity operator, not zero, not optional. The H bar sets the scale at which this difference becomes noticeable, and that I tells you this isn't just a change in value, it's a phase rotation, a shift in how the state itself is oriented. So position and momentum can't both be simple variables. But when the scale of the system is much larger than H bar, this effect becomes negligible. X and P start to behave like numbers. The state is still there, but you no longer need its full structure to describe the system. Everything behaves as if order doesn't matter. That's classical physics, a limit of this deeper behavior, but the structure never disappears. And everything looks classical until you zoom in, but underneath, order is physical.